Hi, my name is Will Pincek. I work for Juniper Networks in the Education Services Department. I'm going to do a learning byte here on Contrail Enterprise Multicloud, specifically the the fabric management features of doing centralized routing. So what is centralized routing? Okay, this is the ability to allow routing of traffic between different overlay networks, between different Contrail overlay networks. It does not allow by itself the routing of traffic between an overlay network and the underlay or the internet, for instance. Okay, it's only between these private VXLAN segments. Um, so routing is going to be performed on the spine, and that's the reason why we call it centralized routing, is because it's going to be done on the spine of an IP fabric instead of on the leaf. Which would be called edge routing. We're not doing edge routing here. We're doing routing in the spine, okay, between the overlay networks. So what does that look like? Well, first off, let's look at the logical look here, which is in our example, we're going to have a virtual machine attached to a virtual network A, okay? We're going to have a bare metal server attached to virtual network B. We're going to do that by attaching a bare metal server to a QFX 5100 and configure that QFX 5100 as a layer 2 VXLAN gateway. That's how we'll get it into the overlay network. It turns out we're not going to configure that by hand. Contrail Enterprise Multicloud is going to configure that for us. The main benefit of Contrail Enterprise Multicloud is that all this configuration of the bridge domain and all that good stuff will be done for us, okay, by Contrail Enterprise Multicloud. Uh, okay, and then we're going to be able to route between them through this thing we call a logical router. Now the logical router actually shows up in the command user interface. You configure a logical router, you'll associate this virtual network to that logical router, and you'll specify which spine devices this will be extended to. And so in our case, we have one spine device, so we're only going to associate this logical router with one spine device. But what actually happens on the QFX 5100, QFX 10K, we'll show you in a second, okay? First off, I want to show you first what happens at the leaf, which is kind of the point of this slide, is that first off, on the compute node from the VM, you know, the QFX 5100 at this point, when it comes to forwarding traffic from this VM, we'll just see VXLAN packets coming in and out from this VXLAN tunnel here. That actually will traverse this path as opposed to around here and wherever this is. But it's actually going to be across this path here. It won't act as a layer 2 VXLAN gateway. It just forwards IP packets at this point. So it's going to be the V router that encapsulates any traffic from the VM into VXLAN to transport it between itself and its gateway being the QFX 10K. Okay, and one thing to note is that to advertise the MAC addresses or the routes, the Contrail control node will advertise the actual /32 network, this .100 network, 192.168.1.100/32 network as a type 5. That's the way Contrail does it by default. So the advertisement, the EVPN advertisement that goes up here to the QFX 10K from the control node, which does all the advertising, will be a type 5. Okay. Now on the 5100 side, this MAC address will get advertised as a type 2 advertisement, EVPN type 2 advertisement up to the QFX 10K. And that's important to note when we get to the next page and we talk about what goes on the QFX 10K here. Okay. And the reason why type 2s are sent is because the QFX 5100 only supports type 2s. It doesn't support type 5. So when we go here, here's the logical look of the QFX 10K. Remember, we had a VXLAN tunnel coming in from the QFX 5102. We see it here terminating on the VNB's bridge domain on the default switch of the QFX 5100, QFX 10K, that's the main box here. The whole box is a QFX 10K. And then we also had a VXLAN tunnel coming in from the V router on the compute node. Now what we'll notice is that it terminates on the routing instance, okay, which is different. It doesn't terminate on the bridge domain associated with virtual network. And the reason why is because the advertisement for that VM was not an advertisement of a MAC address, a type 2. It was an advertisement of a /32 network. and it gets placed in this routing instance. 192.168.1.100/32 gets associated with the next hop of the tunnel back to the V router. So it's different routing to get to the VM as opposed to getting to the QFX 5100, which would be for any route for traffic coming in this way, destined for the bare metal server, which is on 192.168.2. It would get routed through this route here, which is the /24, next hop of the IRB. It gets encapsulated in layer 2 framing and gets switched out of here, and the MAC address of the BMS would be associated with the next hop of the VXLAN tunnel. So that's how routing is going to look for traffic between a VM and the bare metal server. Now, a thing to note here is that we see that there's a bridge domain for VMB, there's a bridge domain for VNA, there's an IRB attached to each bridge domain. There is a gateway address associated with that IRB, and there's also a routing instance configured. All of this routing instance is the representation on this QFX 10K for this logical router. This is exactly it. That logical router, but it's actually a layer 3 VPN BRF is what it is. Okay, all of this stuff you see here gets auto configured by Contrail Enterprise Multicloud. So just keep that in mind, that's a lot of stuff. Okay, and if you had to do that by hand, it would be very tedious. But Contrail Enterprise Multicloud makes it very, very easy. Now, in order to do this, okay, you need some things that are prerequisites, right? First, you have to have a Contrail cluster that has Contrail command installed. That user interface has to be in place in order to support what we're about to do. VXLAN routing has to be enabled. This has to be enabled in order to support the routing on the spine. And then onboarding, we have to have an onboarded IP fabric, whether it's greenfield or brownfield, with an EVPN VXLAN overlay signaling that is established, which you'll see a diagram here in the next slide. And then the spine nodes need to have the CRB gateway role assigned, okay, to do the centralized routing. Okay, that's the role. That's what it's doing. This is the CRB gateway role. When you talk about what is the CRB gateway role, this is it. Everything I described right here, the routing instance, the bridge domains, the routing, the IRB interfaces. This is the centralized routing CRB gateway role. Okay, and then the CRB access role is, the layer 2 VXLAN gateway role that I talked about here, which is this one here. Okay, so the spine and leaf devices have to be assigned their appropriate role. So just talking about an onboarded IP fabric, we have one in our lab right now. That's what we're going to use, okay, to demonstrate. I've got a Contrail cluster installed. I've got some of the nodes are off of QFX 5101. The compute 2 is off of QFX 5102. But I have an OpenStack node that does the OpenStack orchestration. I've got a Contrail control node. I've got 2 compute nodes that do the OpenStack compute or Contrail vRouter function. So that's compute 1 and compute 2. And then we have the CSN that will be able to do DNS and DHCP for any bare metal servers that we add to the network. So that's our Contrail control node, and then up here we have the command server installed as well that hosts the command UI. All of this has to be in there, and all of the fabric nodes need to be reachable by these nodes. Okay. I have an onboarded IP fabric. Okay, so I had eBGP turned on for the underlay so that routing can happen between these subnets. Okay. Then I used the command UI to onboard this IP fabric, which established an EVPN overlay, which is what you're seeing here with these red dotted lines. The control node, the 5101, 5102, and the 10K have all been enabled for iBGP EVPN sessions here. So that's what we're seeing here. So from the QFX 10K, which is acting as a route reflector, has a EVPN session with the control node, the 5101, and the 5102, and it's acting as a route reflector. So any routes received 5102 will get sent out to all of its clients. So all good. So this is established. So what we're going to do, if I go back, remember, this is what we're trying to build. Okay, we're trying to be able to route between VM1 and bare metal server through the QFX 10K. So that's what we're going to try and build out here in a second. So let's go through our steps. Okay, I want to verify my MP-BGP session. So remember, the 10K is acting as the route reflector. If I go to the 10K, which is here, and I say show BGP summary, I should see, number one, a couple sessions. These are my eBGP sessions for the underlay. But if you look here, I've got EVPN sessions to QFX 5101, QFX 5102, and the Contrail control node, and they're all established, okay? So they're all established, that's good. So we've verified that. We want to verify the CRB roles of the fabric devices, okay? If I go to Contrail command node, I hear under infrastructure fabrics, I see that I have an onboarded fabrics, I called it brownfield. Here are my devices. I've got the 10K, the 5101, 5102. And what I want to do is verify their roles, which I can do that right here by just hovering over. The 10K is doing the route reflector role, and also the one I care about is the CRB gateway role. The DC gateway role is for another learning byte I did, so it's unnecessary in this case. But you can have it there as well. And then the leaf devices are in CRB, have the CRB access role assigned. So that's all good. So we verified that. We want to verify VXLAN routing. We can't do centralized routing unless we've got that turned on. We check it under projects, admin, and we make sure that this slide button has been enabled, and it has. Then we need to verify the CSN is assigned to the CRB devices. Now remember, if we go back to our diagram, the bare metal server is going to get its IP address from DHCP. It's going to get that from the CSN. The CSN is actually going to attach itself to this overlay network, to this virtual network B. It does that to provide DHCP and DNS server services to it. So that's why what we need to do is we need to make sure that 5102 is associated with this CSN. Without doing that, this CSN can't service this bare metal server. So we have to go and check the settings that we've done that, which we have, but we'll verify it right now by going to we go to under here, we go to fabric, we go to brownfield, and remember it was 5102 we need to be associated with the CSN. We go down here and we see our associated service nodes. We've got a top of rack service node called CSN associated with it. And you can associate this particular CSN with as many top of rack switches as you want. Okay, but or you can load balance across several. But anyways, this is it's assigned. So we verified that. We also want to modify our default security group so we allow ingress traffic to our bare metal server. So we go to infrastructure, security groups, because by default, both the VM and the bare metal server will be associated with this Contrail security group. Okay, and on my default security group, I want to modify this to allow ingress traffic. So in the ingress direction for IPv4, I want to allow all traffic. So that's why, luckily, it's defaulted to 00. For IPv6 ingress direction, I want to allow it for the default route as well. Egress already defaults to 00, so we're good. So we've modified our security group there. Then we need to create our virtual networks. We're going to create two, virtual network A and virtual network B. And let's look at that real quick. Okay, so virtual network A, which is 192.168.1.0, and virtual network B is 192.168.2.0. So let's go over here in our Contrail command user interface, and we'll go to virtual networks, and we're going to create our two virtual networks. We're going to create virtual network A. We're going to add a subnet from the default IPAM. A was going to be 1.0. Our DHCP pools will be 1.100 through 1.1.110. And we're going to provide DHCP and DNS services, and I'll hit create. Okay, that creates that one. And I want to create one more, which is VNB. I want to add a subnet, the default IPAM, 192.168.2, 2.100, 2.110, DHCP and DNS, and I want to hit create. Okay, so I created my virtual network. Now I need to be able to create my logical router. Again, in order to provide this, to do this, we need to associate this logical router here and associate it with this 2 virtual network. Okay, so we're going to do that on the QFX10K, and that's what this function will do. So I go and create my logic. So let's go to under overlay, under logical routers. We're going to create a new one. Okay, I'll call it LR1. Okay, we're going to extend it to the QFX10K. The networks it's going to route between is VNA and VNB. Now, is this a public logical router? Do we want to be able to route out to the internet? In this case, no. If we wanted to route to the internet, we would select that box, okay? I have a separate learning byte on the QFX10K acting as a data center gateway, a DC gateway, that you can look at if you want to look at that. But for now, we're not doing that. We're just going to do routing between these virtual networks. I say create. Now, what's going to happen by doing that, let me just verify. Yes, so here, once I do that, it's actually going to create that config for you on the QFX10K. Now, it takes quite a while to do. If you want to watch it happen, you can watch the Ansible logs, which is what I like to troubleshoot. Or the way I like to watch it happen, I go tail minus F, var log, contrail fabric Ansible log. And here, now it's actually building the config for the routing instance and the bridge domains. This is all being built. Now these routes, these /24s will probably get populated and associated with these IRBs, but this .100/32 won't get there until we actually build the VM on Contrail. But all this right now is being automatically configured by Contrail Enterprise Multicloud. That's what it's doing. So let's make sure it's done. So it takes quite a while to do, and it's still running. So I'm going to pause this until it finishes. Okay, so now the building of the logical router or the routing instance on the spine is done. So I can actually go look at that on the 10K. So let's do that. And so what I do is I compare the current active config against some of the older ones. And so I'm going to do that. Show pipe compare rollback 2. And here that I see 2 VNIs have been created, 5 and 6. Okay, those are the two. It turns out, and those will be associated, and there'll be some policy here, good enough. But there's also going to be those 2 IRB interfaces configured with a real IP address and also the virtual gateway address. Okay, which is what we expect. Notice all this config is done for you by Contrail Enterprise Multicloud, which doing it by hand is quite tedious. We've got 2 VLANs, VLAN ID 5 each and 6, each associated with a VN ID for the VXLAN tunnels. We see our that a loopback interface has been created, and that's just to keep this config. When there's no IRB interfaces configured, this routing instance will stay up. But we see here that there's the routing instance, big long name, Contrail generated name, the 2 IRB interfaces associated with it, the VRF import and export policies, and the ability to support type 5 advertisements, which is this config here, okay? Which is how we'll route over to the Contrail compute node, the VM there, okay? And that's it. So all that's been configured for you, but we've got more to do. So we're not done yet. Again, we only had to click a few buttons on Contrail Enterprise Multicloud to auto configure this for you. So let's bring this back to where we do our stuff. Now we need to launch the virtual machine. Okay, remember the VM is going to be attached to VNA. I'm going to launch a virtual machine under instances. Okay, I'm going to create a new virtual instance. I'm going to call it VM1. VM1. I'm going to launch it from a Ceros image that I have. It's going to be a tiny image. I'm going to attach it to VNA. Default security group. That's why we had to modify that security group. And the Nova availability zone. I'm going to create it. Okay, so now OpenStack, it's going to instruct OpenStack to launch a VM and attach it to that network. Okay, so hopefully that worked. Okay, and after that goes down, we need to go and launch our bare metal server. Now, we're going to, I show you how to do I go through all the details of this in another learning byte. So there's one, I believe I do, yeah, and VM to bare metal server bridging. But we'll kind of go through it again. Okay, so this VM's up and running. Okay, and it's given an address of .102, so I didn't get the .100 address I was hoping for, but that's fine. But now that we know that it's .1.102, okay, so that's launched. I can also go back to the 10K to see if it actually advertised. If I remember, this is our routing instance, so I'm going to look at this routing table. If I say, if I exit out of here and I say show route table, okay, and then paste in that name, I can see here that the 1.102/32 route is associated. Notice it says ET0035. Well, where's the VXLAN tunnel? Watch this. If I say show route, that route exactly, okay, and extensive, you'll see here that we have a composite next hop of and where it encapsulates it in the VNI. Okay, all that stuff. So that's where you actually see it as an extensive look. But that's there. Okay, so that's the VM's route. Okay, so now so our VM's up and running. Then what do we need to do? We need to go to, well, let's find out what we need to do. Let's go here. We need to create our bare metal server. Okay, so I'm going to go ahead and create a bare metal server. Go here to servers. I'm going to create a new one. Detailed bare metal server. I'm going to call it BMS. Okay, my bare metal server. I'm going to give it a network interface. It's going to be ETH1. If you look at our diagram, it was ETH1. The MAC address of that one is 17.99. That's the bare metal servers. 17.99. So we'll put that in. This has to be match, or this has to match, or it won't work. If we look at our diagram, this bare metal server is going to attach to GIGI004 on QFX 5102. So let's go there, QFX 5102, GIGI004, which is what we want. Okay, that has to match. And we hit create. Okay, now that just associates the MAC with that bare metal server's interface. Okay, I'm sorry, with that top of rack switches interface. Okay, but now we have to launch it as an instance. So we go under instances, and it's there that we're going to create a new instance from an existing bare metal server from, I'll give it a name called BMS, but the bare metal server, this is the BMS that we created on the previous pages. Going to use its interface and MAC address. The IP address will leave blank because we want it to come from DHCP. We'll say 0, no VLAN tagging. The virtual network it's attached to is VNB, and the default security group. Now we're going to click create. Now this is going to cause the Contrail device manager to go out and configure the QFX 5102 to act as a layer 2 VXLAN gateway. So sure enough, using my tail -F command that I showed you before, I can watch the Ansible playbooks run, okay, and make sure they run correctly. So we're waiting for this to complete before we can actually test the connectivity between the bare metal server and the VM. So I'll go ahead and pause this until this is complete. Okay, so the Ansible scripts have completed, and at this point there should be connectivity between the VM and the bare metal server. But let's talk about what went on there on that last step. On that last step, Contrail Enterprise Multicloud went out and configured this for everything you see here, which is the attachment to the GIGI004 interface, the associating that with the bridge domain, and also enable the VXLAN signaling to support the forwarding of traffic up to the QFX 10K for routing. So let's take a look at that. So that was on QFX 5102. If I say show pipe compare to rollback 1, you'll see all the config that was done for us. We've had a new VNI, right? VNI 6 configured for us. Had some policies configured. We've had our interface enabled and associated with a VLAN and a VXLAN identifier. So this is the configuration of a layer 2 VXLAN gateway already done on behalf of you. You don't even have to really know how EVPN works because it's done for you. So that's all done. So now we just need to make sure there's connectivity. If we remember, and then the last part is, okay, I want to be able to get an IP address on ETH1 of the bare metal server. So here's the bare metal server. I'm going to bring my interface up. Hopefully gets a DHCP address from the CSN, okay, which it does. There it is. And I say IP address. We'll see that the ETH1 is up. It's been given a 102 address. So if I say ping 192.168.2.1 just to ping the gateway, let's try that. 2.1. I'm going to ping its gateway. It pings, no problem. Now let's ping the VM, which was 1.102, if you remember. Sure enough, I'm able to ping, and that's all going through the QFX 10K central routing. Okay, let's verify. Let's take a quick look at the 10K. Remember, we looked at that routing table before. I'm going to look at it again. We see here's that routing table. We have the 1.0 associated with IRB5. We have the 2/24 associated with IRB6. We have the /32 for the VM associated with a VXLAN tunnel. And then let's see, nothing specific in here related to the bare metal server because of the type 2 route, right? So if we look at show Ethernet switching table, we'll look at the bridge domains. Here we have their different bridge domains. I've got bridge domain 6, which is, we see here's the MAC address of the bare metal server and associated with a VXLAN tunnel. That's a representation of a VXLAN tunnel back to QFX 5102. And that's it. I hope that helps. Let's see what we got here. That's it for that one. So in this in this one we described the steps to centrally route traffic between overlay networks. I think we successfully have done that. And I hope you look for some more of my learning bites, and I hope this was helpful.
Visit the Juniper Education Services website to learn more about courses. View our full range of classroom, online, and e-learning courses. Learning paths, industry segment and technology-specific training paths. Juniper Networks Certification Program, the ultimate demonstration of your competence. And the training community. From forums to social media, join the discussion.